Hi class, welcome to PEP 289 with me, Elizabeth Harding. I'm going to take you through the assignment, fitness test z-scores, and normative values. If you haven't had a chance to look at that, go ahead and pull that up. It's on our UNM Learn site under workshops, which is its own content area. And you'll see that the first thing that you need to do with your data set is to sort by males and females. So if you're a female, you're only going to be working with the female data set. And if you're a male, you'll only be working with the male data set. And so to create that, I just sorted by males and females and then deleted all of the male data. Right, so that was the first thing that I did. Right. And you can see that we have quite a few variables so far just with our two labs. And so I'm going to hide some of these columns. I'm not necessarily going to delete them. I just want to get them out of the way so that my workspace just looks a little cleaner. So all of the variables from the first lab, those can be hidden away. So I'm just highlighting the columns. I'm right-clicking and selecting hide. Okay, and so this leaves us with the tests that we did during lab 2. So a few things that you might notice. One, you might notice that I have no empty cells. So what I ended up doing was just deleting any participant that had a missing value. So at least from the lab 2, so from one of the fitness tests. And I just found that that just made the data cleaner. And as it turns out, within the females at least, we have 21 participants, which is a very good number. And we'll talk about statistical power later on in the course. But it's fairly decent. It's not ideal. We want as many participants and as many with as many data points as we can possibly get. But I just felt that for the purposes of this assignment, it was a lot cleaner. And so if you didn't do that, that's fine. But if you haven't really started this project, you might want to go ahead and do that. Just makes it much easier to work with. Okay, so another thing, or a few other things that I did or that I need to do to clean up this data set is we have right hand and left hand grip strength. So, in hindsight, we should have looked at hand dominance and probably looked at the grip strength of the most dominant hand, but we didn't do that. So we're going to go ahead and just calculate an average grip strength. Okay, again, this isn't ideal, but how I did this was I just created a new column and then just averaged the right and the left. So create the formula in Excel and then, double clicked quickly or drag it all the way down. So it makes it very easy and very fast. All right, so now this is the variable we're going to be using. And so I can just hide these two. Let me show you what happens, though. I should probably go back. I'm going to show you what happens if I were to delete these columns. Okay, so you can see that this new column that I made, the average grip strength, no longer has the cells to reference. So in this case, it's much better. Sorry, I'm going to Command Z here, there. And it's much better to just go ahead and hide. And that way your data stays intact. Okay. So another thing that another issue in this particular data set is our vertical jump. So as you can see here, vertical jump in inches and standing reach height in inches. And so what I think happened, say, with this first participant is that the standing reach height was 92, but then they just added their vertical jump on top. And so that's not really a true vertical jump height. And so I've created another column called true vertical jump, in which I've just subtracted the standing reach from the vertical jump height total. And if I carry this formula down, you can see right here, it's this cell minus this cell. If I were to carry this down, it's going to create a problem for those individuals that already took that into account. So you can see right here, I have this negative 60, right? So chances are the 16 is actually their true vertical jump score. So I'm going to go ahead and just reference that cell. So anything that looks a little strange, obviously negative 21.5 might not be completely accurate. Same thing here. Now we have some fairly good jumpers in our class. It's hard to tell. I want to give us the benefit of the doubt. I love to see that the ladies in our two classes are quite strong. However, according to our normative values, and I'm working with two screens, so bear with me. Here are our normative values, and this is also on UNM Learn under the workshops content area. You can see that for women, a rating of excellent in inches is greater than 24. So, quite good to the woman whose vertical jump is 41 inches. So it's hard to tell at this point if that's accurate or not. For now, I'm going to leave it. I'm not going to bother trying to convert it into inches, say if I believed that this was actually centimeters. I'm going to leave it and hope that towards the end of the term, our data set gets updated and is as accurate as possible. Okay, but that's how I dealt with this. And so now I can get rid of standing reach height, or not get rid of, but hide standing reach height and the vertical jump. So I am left with these 5 variables. Okay, so the second thing that you need to do is to calculate the mode, the median, mean, variance, and standard deviation for each of these 5 tests. So you're only working with females if you're female and males if you're male. So don't worry about having to go back and do this for the other gender. But what I'm going to do is I'm going to highlight this here and copy. So I just highlighted the headers, hit Command C, or alternatively right click and copy, and I'm going to paste those headers just right underneath each column. Sorry for the long pause there. All right, so we're going to calculate the mean, median, the mode, the standard. Actually, let's start with variance, and the standard deviation. Okay. All right, so I'm just going to work with just the push-ups and get all of these calculated first. Okay, so equals average. And I think most of you are well on your way to completing this part of the assignment. Median. And equals mode. So you do have to highlight all data points and variance. Oops. So for the formula variance, we're going to use var or var.s and parentheses and highlight. And then our standard deviation, we're going to use stdev.s again for sample. All right, and there we go. All right, so what I can do is highlight, and if I carry this over, it's actually going to calculate each one of those variables for each of my fitness tests. Okay, and we can check this. So why don't we check this just to make sure our formula transferred over and nothing got in the way. Let's look at median for grip strength. So I'm going to come over here and we're looking for a value of 30.5. So it equals median. And let's highlight the grip strength. And there we go. Value of 30.5. So our formula worked, looks good. And now we can copy this table and put this into our Word document. So let's format a little bit. Go ahead and maybe give it some borders. This little border function right here. Maybe how about giving the headers a nice background color. And then let's go ahead and highlight this. And I'm just going to right click. And let's find my Word document. Oops. rid of this. Okay. And so I just essentially copied and pasted. And there we go. All right, looks good. And then you can see I put, I had already worked on that a little bit just to make sure it was going to work. You can see I've already added a little header here or description of the table, above the table. And what I should say, I have measures of central tendency and variability for 5 tests of strength, power, and flexibility. And I probably should say in females. And then I can maybe give some interesting descriptive statistics on our female population as far as the N value and maybe their age. But right now, that looks good. It's what's required in the assignment. Just something that's kind of sticking out to me, though, is the fact that things aren't necessarily aligned as I would like them to be. So I'm just going to highlight and then go to table layout and that align here. And I'm just going to center everything. And that just, to me, that looks just a little nicer. Okay. All right, so that's how I transferred a table, or our table, into Excel. And I want to leave this here, and the reason is because we're going to calculate z-scores. So going up, calculating the z-score for push-ups, I'm going to go ahead and make a new column here. Okay, and so the third part of your assignment is to calculate your z-score for at least 3 of the 5 tests. And so to do that, the z-score is going to equal your score over the mean divided by the standard deviation. So I'm going to select a score of 30. So I'm subject, this isn't actually the subject number 14, but this happens to be the row that this falls on. So we'll just pretend that this is subject 14. Okay, so I need to make sure I put my parentheses in there. So score minus the mean score. So going down, always try to reference a cell if you can, instead of typing in the numbers. Fewer mistakes are made that way. And this is divided by the standard deviation. Going up. And again, Excel is going to follow order of operations. So if you didn't have the parenthesis here, it would divide this value, your mean, before it would actually subtract the score from the mean. So just keep that in mind and always try to keep your parentheses. And if something doesn't look right, it might have to do with parentheses. Okay, so here is my z-score. So z-scores typically just go to 2 decimal places beyond the decimal point. So I'm going to round that up just a little bit to 0.13. So here is my z-score for push-ups. .13, and if I look at the z-table, here's our normative values for the z-table. Okay, these are the negative values. We want to go positive, so to the right side of the mean. So 0.1 here, and 3. So 0.13. So that area under the curve, this 0.5517, and I'm just going to copy. So I'm actually, it will copy and paste. So I'm just going to Command C or Control C for you guys that use PCs, and B, and there you go. So there is my, essentially the percentile. So according to this, a z-score of 0.13 falls in the 55th percentile of the women in the class. And if we look at the normative values, for, oh, sorry, Wow, it just doesn't want to do that. Sorry, hang on. That's what happens when I have too many screens going at one time. All right, if we look at the normative values for push-ups. So women, and I'm just assuming just because the majority of the women in our class are probably within the 20 to 29 age group, a score of greater than or equal to 30 is excellent. Right? So it seems if you were to compare this, so if I were to just say, well, according to normative values, it's excellent. So what this could mean is just that, you know, the population that we pulled from just happened to be extra strong as far as their upper body strength was concerned, because the 55th percentile, it's average, but it's not necessary. You wouldn't consider it excellent, right? So it's interesting, and this is maybe a great example of a sample of convenience and not a random sample of all women, you know, 20 to 29. So chances are the women in our two classes are very fit and very strong. So anyways, that is how you calculate your Z-score, and I've given you an example table of how you can go ahead and enter in that data. Right, so the last thing that you need to do is a frequency distribution of the three tests that you've chosen. And so I did an example of a frequency distribution using the Crunches score. So I'm just going to flip to a different sheet. So we're going to use Crunches. And just for convenience's sake, because this would just be a review, and I'm sure you already know how to do this, I've gone ahead and used bins. And the reason is because we have a pretty wide range. So if you look over here, the maximum number of crunches completed was 82 and the minimum was 40. So that would make for a very cluttered x-axis. And so I decided to go ahead and create bins. And I thought 11 would be a good number. And so we're going to have, say, 11 points on the x-axis of our frequency distribution for crunches. So you can see I calculated the range, and then I looked at the interval size by just dividing by 11. And I thought that, say, 3.8, or we can even round this up to 4, would be a pretty decent interval. So I went ahead and started with 82, and then from here just subtracted 4 to get the upper values of the bins that I'm going to use in my frequency formula. And then for as far as the bins for graph was concerned, just so that it looked really nice, I went ahead and just typed some text to correspond with these values here. Okay, and then the frequency formula, just for review, it's the data array, which is the number of crunches. So you highlight the crunches, and then comma, and then your bins array. And you want to make sure you put your dollar signs in front of your data, your first cell of your data point, and then the last cell of your data point. And just to be clean, because we do in fact have some things going on underneath, or I may have had at one time at least things underneath this column here. I just want to make sure that Excel stops at this last cell in my bins array, which is why I put dollar signs just in front of the N22. So here's okay. It doesn't really, that doesn't make a lot of sense. I'm sorry, I'm going to fix this really quick. So here's my bins. And I'm going to put dollar signs. Yeah, so apparently it went down to 22, but it only needed to really go down, say, 13 rows. Oops. Okay, and it shouldn't change anything. And then if I were to sum these values here to check, I should get 21 because we have 21 participants in our study. Okay, and so then to graph this, I am going to insert a chart. And that is really unfortunate because that is not what I wanted at all. But apparently I was highlighting some data, so we're going to move over a little bit because I would like to see a blank slate. Here we go. Okay. So then right click, select your data. We'll call this frequency. And then our Y values are our frequency counts. And our X values, our X labels, are these bins for graph. And I want to say this goes to row 12. I should have maybe had the foresight to move my drop-down boxes. Okay, let's see how that looks. That looks good. Okay, so of course we want to get rid of, and then we can go ahead and spread this out quite a bit to make those that x-axis look pretty nice. And there is the frequency distribution for the 21 females in the 2 classes as far as push-ups are concerned. And so one thing that you might want to do is, I mean, we can definitely clean up this white space, but how about we not worry about that right now? And how about we just copy this into our Word document. Here's my Word document. So I just right-clicked and copied, and now we're pasting. There we go. Okay, mess with it a little bit. You might need to go back and forth to Excel, maybe change the font size here. This doesn't necessarily look very pretty, but I definitely have the confidence in you that you could fix that yourself and make that look really nice. And of course, you're going to want to put some sort of caption underneath figure 1, and then some very clever explanation of what's happening. Right, so that is your assignment. If you have any questions, please email me at hardinge@unm.edu, or you can talk to me before or after class. All right, see you soon. Thanks.